Hey everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Youssef, who has just completed the course ROS2 Basics with Python, and he'll be giving us a presentation on that. So without further ado, let me now hand over the platform to him so that he can begin his presentation. Alright, whenever you're ready, Youssef.
Hello everyone, my name is Youssef. I'll be presenting the ROS2 Basics in Python project today. This project consists of three major parts. So the first part, each part we're going to be creating a node, but for the first part, we're going to be creating a wall follower node where the robot, the Turtlebot robot we have here on the left, will be following a circular path around the whole circuit. And then for the two extra nodes, those will be one service and one action. So the service will be to find the wall. So the whole purpose of this project is for the robot to turn around the circuit, but also to keep the wall on its right. So it always has to maintain a specific distance from the wall, which is from 0.2 to 0.3 meters. And then has to use this laser scan data, which it intercepts or receives from its LiDAR sensor to know where it's at and to find the wall. So whenever we call that service, it's going to look for the wall, maintain the distance, find the distance that's correct, and then start following the wall. And then the action that we call at the start of the program is to start odom recording. So odom is a topic for that to record the odometry, and it will record how much distance, for the distance it took to travel the whole path, and the time, the velocity too. But for now, we're just concerned with the total distance.
Okay.
So that's the whole project. Let's now go into our source directory, which is ROS2 source, or the workspace. And then we'll go into source, and we'll go into the package that we created, which is called wall follower. So if you see, actually, we have two packages here. We have one wall follower package, and we have one follower custom interfaces package. I'll just expand it just so you can see the name.
Yep.
The custom interface package is created to hold the two interface types, which is one for the service and one for the action. So as you can see, we have one actionful directory here, which is for the odom recording action.
Yes.
We'll go into detail for that later, but this is the template. And then we have the service one, which is for the find wall service. And then this is the interface right now. Nothing too fancy, but we'll go into that later. I just wanted to show off that I separated both of them, just to not cause any issues, because this uses the CMake build, and then this uses Python. Does that make sense?
Yes, understood.
Okay. All right. Now let's go into the wall follower package, and let's start with the first node, which is wall following. So let me expand this. So this is our wall following node. Can I ask you one question, please?
Go ahead.
How much do you want me to explain the code?
So at the moment, you must take as little time as possible so that you can show the code working on the robot, and if you still have time, we can get in more detail. But right now you're doing fine. Just keep that speed.
Okay. All right. So this is the wall follower node. I'm not going to describe everything here. The things to know though, it subscribes to laser scan, which I was talking about earlier for the LiDAR. It creates a service client, because we will be calling the service from the find wall service, and we'll be creating a self-action client. So this will be the main program that we're running, the node. It will be calling both services and the actions, and then it will be proceeding with its behavior. So these are just a few attributes which we'll use throughout the whole program. These are very important attributes, actually, because we do have to specify where's the right angle, where's the front angle, where's the left angle. I guess the left angle doesn't matter here, but the right and front, just so we can know or we can target a specific ranges that the LiDAR is giving us, or the laser scan is giving us, and then we can know if something's on the right, something's on the front, we can target them specifically. So this is where we specify all that. This is the function to send the request for the service. This is the function to do something after the find wall service receives a response. This is for the send goal, so this is for the action. This is also another one for the action, and then another one for the action. These are just the normal callback functions for the actions, which we'll go into detail later if we get some time to do.
All right.
This is the feedback call. Okay. Now let's go into the laser scan callback, which is one important feature of our whole program. In this laser scan feedback, a callback, we create a min bound and a max bound, and then we, again, like I said, we receive the ranges from the laser scan data, which is a vector of ones and zeros, or ones and zeros, telling us where. No, sorry. This is the ranges that gives you the distances of each specific angle. And let's say an obstacle is in front of you. If it's in the front of you and the whole space on the left and right is empty, it'll tell you that there's a big distance on the left and right, sometimes infinity if it doesn't receive anything. And then on the front, it'll give you the distance between you and the obstacle.
Okay.
So for here, we use the angle that we talked about earlier to specifically target each angle, and then we'll have a closest angle here, which will take in both the right angle, the front angle of all the ranges, and then it'll tell you where the closest angle is. So this will also be useful. But just to know what is useful from this laser scan data, it's self closest angle, which we talked about right now, self distance right, and self distance front. So the distance to the closest obstacle from the front, the distance for the closest obstacle on the right, which is going to be the wall, and then the closest angle in general. It could also be left, it could also be back.
Okay. All right. Let's see this running. Yep. And then we can review later. Yeah.
Okay. Let's do that. So let me go into my workspace. Let's source it, and then let's do call. You call our app. I've done this one more time actually.
Say that again. I didn't get that.
So make sure. No, you're good. You're good. Sorry. I'm just. No. The command is ROS2 call, right? Not.
So you wanna run? I think you can just call ROS to run the executable that you want to run. If you do not have a launch file, I'm assuming.
It'll be fine. Yeah.
Okay. So.
No, sorry. That's why. Okay.
Did you build on source?
I do have a launch file. Yeah. This is going to contain all three programs. Just to make sure I explain it well, it'll have the wall follower node, the recorder action, and the wall finder service. So now I'm going to launch all three of them together in a main launch.
All right, let's see that.
And then we'll focus on the robot.
Okay.
So now, as you can see, it'll be perform. Okay, let me just explain. So if you see these messages, there's a lot of messages. Let me expand this actually. Now there's room for optimization for the robot, because for now what we do is whenever the robot doesn't find the wall, it'll call that service and then it'll locate the wall and then it'll start moving. This also depends on how it was positioned in the first place, how smoothly it's going to run after. It shows. Wait, I don't know if you can see this.
Yep, it's visible, I think. Yeah, it's all good.
This isn't the expected behavior, I'm not gonna lie. It's not supposed to be this slow.
Right, okay, did you build upon connecting to the robot? Did you build your package?
No, because the last time I was using this was working perfectly.
Okay,
so I don't want to mess anything up.
I don't think rebooting would make things so bad, but
Let's try. Yeah, let's try this again.
Yeah,
It's pretty
so
cool. Let me put the position robot in this position again.
yeah, so just terminate that one, and you can remove all the build directory, the log directory, and the install, and then we recreate it using a program. Yep, then yep. Yeah, then let's build again. Yep. Okay, it's done.
Now let's redo this.
Don't forget to source. You didn't source your new.
No, I didn't. Okay. Sorry.
So just Control C, and then you can source install setup.bash.
Try this again. Now the first thing is going to call the service to find wall. It's going to look for the wall. Now, as you can see, I think it found it. So now it's going to be performing the behavior. It's going to move away from the wall when it is too close. And then it's going to move. This is very slow.
Yeah, I do notice it's also attacking. At what frequency are your velocity commands being published? Are you using like the 10 milliseconds waiting time? Let's see in your wall follower. Yeah, just hang on, scroll up.
It shouldn't be here. Should be down a little bit. Let me just check. I think I know where it is.
Yeah, so we could try increase that to just see if it can move a lot smoother. So timer, okay.
I've defined any frequency here.
Okay, so
The thing is, it might be the frequency.
it's moving, but I guess it's just the decision of figuring out.
It is. This is what it's. So what it's supposed to do is at first it finds the wall, and then once it finds it, it
must not keep looking for the wall, right?
Yes, the find wall step. The find wall service has 3 steps. So it turns to the wall, goes directly to the wall, and then once it reaches 0.2 meters, it goes back left and it goes front, so it can go back to wall following behavior, and then it should speed up, not speed up a little bit and then go for the wall again.
Okay, so you designed it in such a way that it calls the find wall after how long? Because normally it's supposed to just find the wall once and then keep it on the right as always. Yeah.
See, that is true. That is what was given in the instructions, but I thought we might as well use the service if we ever need it again. So whenever the wall follow behavior, it either approaches the wall when it's too far away from it, or it goes further away. So when it has to approach the wall, when it can't find it, I gave it a time limit. So when it does that for more than 10 seconds, I think it was 10 seconds. I might have changed it. It redoes that service again.
Okay, all right. So after 10 seconds, had you noticed that it was drifting away from the wall so much so that you had to actually call it again?
I think at first I did 10 seconds. I found it was doing that for too much, so I reduced the
Hmm.
speed. But the find wall service, it's very fast. Is because the robot's not going to deviate too much from its path. So
Yeah,
as soon as
understood.
it deviate a little bit, yeah, it'll do that service in 5 seconds.
Yeah, okay, so
Like as you can see
no,
now, that's the service done.
yeah, I can see that. So okay, normally you must you must deal with this issue of deviation from the wall in the control algorithm that follows the wall, right? So that you don't have to have it look for the wall every time. But yeah, it's an interesting solution. I understand where you're coming from. Um, but under normal circumstances, you must do that control of eliminating deviation from the wall or minimizing the distance between the robot and the wall in the control algorithm itself, that is in the wall follower itself. um,
Well,
it,
it does do that, but not to a certain extent, like you said. Yeah, that's
uh-huh.
true.
Okay, yeah, it's good. So okay, let's see the odometry output to see how it's
So
working.
that is another thing that's also unexpected because when I used it before, it stopped the robot when it did reach that um,
But it
location.
did it I would want to know, did it manage to track the distance as the robot went round, right? So like we can stop
Yeah,
it
so it is
now,
it.
so and run the odometry script as well concurrently as the robot goes around the loop, so that we see that it's working to track the distance. At least stopping is a different criteria.
Now, the distance is being recorded here. If you can see, total distance traveled by currently is 8 point. This is from the action node.
Okay, so this is the one that's
This is the
supposed
ODOM
to,
recorder.
okay, all right, and this is the one that's supposed to check the proximity to the starting point to stop it, correct?
Yes.
Okay.
Yes, which did work before. No. Again, I can't prove that to you.
Yeah, there are some variations where it might work and where it might not work, but the good thing is that it's working, so that's good. So how many times did you try, and how many times did it work? Do you have a record of that, or like you can?
I tried it at least 2 to 3 times
And it,
for the last iteration, and it did
okay,
work perfectly.
okay, in all cases.
I don't know. Yeah, in all cases, yeah.
Okay, all right.
The stopping. Are you talking about the stopping the robot feature?
Yes, that's the one I'm talking about. Yeah.
Yes, no, the stopping the robot feature worked for me like at least 10 times. But
All
I'm
right.
saying the last iteration for the path falling, that one was working at a good speed for 3 times.
Okay, all right. I understand. Yeah.
I don't know as you can see now. I think this is very slow now. Yeah.
Yeah, but it's good. It's good. All right. Let's get into some more details that you wanted to explain. You can just stop the execution of the script, and then we can talk about the code a little bit more.
Well, I apologize for the very slow robot.
No, it's good. It's understandable. So these things do happen sometimes.
Yeah, thank you. Well, let's talk about. So let's first of all go into the question you asked me about, not the question, but the concern you raised,
Mm-hmm.
which was the control algorithm, the wall follower not being tasked to do the wall following itself.
Mm-hmm.
So so here we have a little function called navigate robot. This is what's going to be called every time
Mm-hmm.
we like there's a loop with the timer. And then yeah, so the wall following node. That is what creates it. I think there should be a timer here. While following that. Sure. Okay, yeah, there we go. So laser's
Okay.
gonna call back at first. It's gonna keep looking for the LiDAR data, and then once the service is done,
Mm-hmm.
it's gonna navigate the robot. So once the find wall service is done, it navigates the robot. If the find wall service is not done, then it will stop this navigation program. So what this does every time it's executed, it will look for the front. it'll check if it's under 0.3 meters.
Mm-hmm.
In that case, it'll slow the robot down because you don't want to bump into the wall. So that's the first check.
Yeah.
The second check is to look for the distance on the right, and to know how if it's too big, the distance on the right, then it has to approach the wall. So
Mm-hmm.
this is where the control algorithm is approaching the wall here. You can see this little log message. So this is
Yeah.
where I put the threshold turn duration. If it keeps on turning too much, you don't want it to turn into the wall too, and you
Okay.
don't want it to keep on turning on its place too much.
I
So
see.
that's when if it keeps on turning for more than, let me go find the exact duration I gave. So I changed it to 3.
All right.
That is why it keeps on doing that for a lot. Yeah.
Yeah.
If it does that for more than that duration, then it stops. It redoes the service again, and then it sends the request. So it'll say service done, false, and so the later it's going to call back. This won't be called again.
Mm-hmm. All right. So
Again, for the other behavior, yeah. Sorry.
no, it's okay. You can go ahead.
Okay. Just to speed up, that was what I wanted to target specifically. The other ones are if it's too far away, if it's more than 0.2 meters, then it will move away. Sorry, if it's too close,
Okay.
under
I see.
0.2 meters, it will move away from the wall.
Yeah. Yeah. Okay. All right.
And
All right.
then
I see where
otherwise,
you're
it'll
going.
yeah.
Okay,
Okay.
so this is the part
Um,
where I was saying you could have implemented some type of bounce checking where you just monitor the distance to the wall. So you would monitor like your right laser scan data, right? So the one at 90
yeah.
degrees to the wall. I think that
Exactly.
would make it
Mhm.
easier. But now that you have managed to get this working, that would be quite easy for you, I think. It's just a different way of doing
Well,
it because I think it's. Go ahead.
Sorry, but I do have a distance for the 90 degrees. Of course, there's a little window, so it's not exactly 90 degrees. It's 90 minus 5, so 85 to 95, and I'll
Okay,
give the
so.
closest distance for that
Uh,
range.
All right. So you're checking like what's slightly in front and to the right.
Yeah.
Okay. And what happens if you? So out of interest, what happens if you eliminate the whole like find wall service? Like if you eliminate that core altogether, did it underperform to your expectation? What did you discover?
Yes, I underperformed a lot. I found that
Okay. All right.
it keeps on approaching the wall too much,
Too
and
much.
it's not regular at all. I feel like if right here, or at least the version that worked perfectly,
Mm-hmm.
it would find the wall and then it would be aligned on its path, so it
Mm.
wouldn't have to do too much turning and shifting. So it would go straight, and then it would only do the find wall service in the corners where it would. So I set it to go to straight to the wall, increase the speed every time it goes straight. So there's a counter. Every time it's straight, it increases, and then once it reaches the wall that's in front of it, once it detects the wall in front of it, it'll do a slight turn, and then that's when it starts doing the find wall service, and then it repeats that straight wall, does the service again, straight wall, does the service again. So that's why it was fast. I don't know why it's not doing that now.
Yeah, okay. It's good. I like your implementation. I think it brings very good variation. So yeah, but wonderful. Thank you so much, Youssef. So we'll
Thank
wrap
you,
it up
Azir.
here, and you
Yeah.
just hang on, okay?
Well, yeah, thank you so much. I guess if you have another question, let me know, please. But it was great working on this robot.
Okay, sure. So just saying, so all right, everyone. This was Yusuf's presentation, and really did like the way he approached the problem, and it's good. It's inspiring. It also shows how you could go about solving these problems, and we encourage all those of you who would like to give this project a shot to do so, and you can also come and showcase your work. And until next time, keep pushing your ROS learning. Bye bye.